Okay, guys, good morning. Today we're going to go and talk about 5.4, solving compound inequalities. So we're going to solve compound inequalities containing the word and graphing their solution set. Solve compound inequalities containing the word or and graph their solution set. So compound, you know, like you can go to science where it's two things put together, I guess, two elements. I don't know exactly what it is. Or you can go to ELA when they say compound subject, when you have two people or two things doing something, or compound predicate, two things being done. You can think about it. So that's what a compound is. You're going to have basically two inequalities, and let's put them together. Okay, inequalities contain and, when considered together, two inequalities such as v is greater than or equal to 4 and v is less than 18 form a compound inequality. A compound inequality containing and is only true if both inequalities are true. Its graph is where the graphs of the two inequalities overlap. Okay, this is called the intersection of the two graphs. Now, this happens in the real world. Like you can go on a field trip if you, how about this, grade higher than 85, and you, I don't know, bring in the money for the entry to Six Flags, whatever. So you have two kind of things set up, two kind of parameters set up. Can you bring more money? Yes. Can you have a higher grade? Yes. As long as you satisfy both of those conditions, you're good. And that's it. That's what it's talking about here. So the intersection can be found by graphing each inequality and then determining where the graphs intersect. So when it comes to this one right here, this is this inequality. Remember, variable on the left, shade to the right. This one here, shade to the left. No, okay, no shaded in circle here, I'm sorry. Now, where do they overlap? Now, you do want to set these number lines up kind of, you see this? Where they're in order, or they match each other up, okay? I do not want to have a number line, I do not want to graph this one over here and put a 3 over here, way over here, and then graph this one over here and I put a 7 over here. You got that? That doesn't even make sense. On a number line, the 3 would be about here, and again, the 7 would be maybe about over here. So you see how I tell you to do cheapy ones? Okay, this is a cheapy one, and this is a cheapy one. I don't mind, but as long as the 7 would be on the right-hand side of this. This part right here matches up, so that's cool with me, but don't do it the way I showed you and put like the 7 over here, or put the 7 right here in line with it. Because now you're doing compound. You're doing two inequalities at the same time. Now, this right here is the answer. You see how this part and this part, so you bring this down here. And it only goes good until right here. So this is your final answer right here. Pretty cool, right? Now, the way you're going to write this one out, this is your answer right here. This is your answer. Since we're talking about x's, okay? X is in the middle. What's my lower bound? 3. You see this? 3. What's my upper bound? 7. It's included, so always just put this. I always say, don't think about it. Put this right there, and that. See that? Not included, so no underline, no equal sign there here. And that is how you get this. Okay, let me explain that one more time. So when it comes to coming up with this one right here, you want to first graph this one right here. And graph this one right here. Notice the answer. The answer is where this one goes this way and where this one goes this way, and they overlap. See, this is the overlap part. Now the overlapping, to get the correct answer, this is your final answer here. Get the lower bound, guys, 3. Get the upper bound here. Since we're talking about 7s, it could be y's, x's, t's, whatever you want to talk about it. X is here. Don't think about it. Put this symbol here. Put this symbol here. This says that x is greater than 3, and this is x is less than 7. So basically, if you think about it, it's greater than 3 and less than 7. So x is stuck in between these two things. Makes sense. Now, is it shaded here? Yes, it is. So it goes with the equal sign here. Not shaded, no equal sign. And there's your final answer. Okay, let's go and look at this real quick. When we come to this part real quick, you're going to come out here and break this one up into two things. Hold on. Okay, so now it's given to you like this. This one looks really weird, but basically you see this part? Boom. There it is. You see this part? And there it is. Solve both and get it done. Look at the way this is written. When it's written like this is an AND statement, okay? So first express the first one, okay? We're going to come out here to the red side, to this red side. See it right here. We want that x by itself, so we're going to add 3. We wind up with this as my answer. Graph it. That's this part right here, right? Now, in this situation right here, remember, switch the variables around. X here, I want the variable always on the left. I'm eating the x, 1. So from a 1, I'm going to the right. Now this next one over here, I'm going to come out here, switch colors. This part right here, I want the x by itself, add 3. That's what they're doing here, both sides, and we get this. Now from a 7, remember, this is a 1. It's on the left-hand side. A 7 is way over here. Shade to the left. Now regarding this part, the answer is this part and this part together. You see how this one is shooting to the left, this one is shooting to the right? So theoretically, in reality, they kind of overlap right here. So that's my answer. This is kind of my answer, guys. Let's write this now, all right? Remember, my lower bound would be 1. My higher bound would be 7. We're talking about x's, so I'm going to put x in the middle. Don't think about it, and just put these two right here. Included? Yes. The equal sign. Not included? Leave it like that. So my final answer is 1 is less than or equal to x. X is what? Less than 7. And that's actually your answer. We can write it now. Let's go write it more professional, more coolish, set notation. Oh, great. Did I change it too much? Oh, okay, there's the final answer. My bad. I just didn't see it. Okay, let's try 2 on our own real quick. Okay, this one, you see how it's an AND statement? They wrote the AND here. This one, how it's written like this, is an AND statement too. So let's look at this one real quick. Let's see what's going on here. This one says, well, that and that. Well, let me solve this one by itself. I'll do it in red. So I'm going to have y minus 3 is greater than or equal to a negative 11. I'm going to add 3, add 3. These cancel out here. Now I'm left with y is greater than or equal to negative 8. So if I guess I'll do this one here. On a cheapy number line, you know what, let me just do this one. Let me do this one next. Okay, let me do this one. So y minus 3 is less than or equal to negative 8. Let me add 3, y is less than or equal to negative 5. Okay, so now I know now I know what two numbers I'm going to compare. So a negative 8 would be over here. Okay, a negative 5 would be on this side. But from a negative 8, I'm going to the right. And it's shaded in. For this one here, I would have a number line like this. A negative 5 would be on the right-hand side of this one over here. And I would have a negative 5, and I would be going to the left. Shaded in right there. Now, where they intersect, guys, is right here. Okay. You see that? That's where they intersect. So final answer would be like this. What number do I have here? Negative 8. What number do I have here? Negative 5. Now, it is shaded from here, okay, all the way to here, right? So that's your answer. That is your answer where they overlap each other. Final answer. I guess I'll do them back. Okay, my lower bound would be this, negative 8. My upper bound would be negative 5. And I'm going to put, since we're talking about y's, I'll put a y here in the middle. I'm going to put this and this. Both of them are shaded. And there's my final answer. Now we're going to say y is the answer such that, the set of y is the answer such that y, if you think about this, is between a negative 8 and a negative 5. And it can be equal to it. Okay, let's try this one right here. Make sure you know this one here is an and, again, the way it's written down. 6 less than or equal to r plus 7. And we're going to have this part here. R plus 7 is less than a 10. We have both of these together. We need to solve them out. So the red side here, I'm going to go ahead and subtract 7. Subtract 7. These cancel out here. We're going to go with negative 1 is less than or equal to r. I'm going to switch these around. R greater than or equal to a negative 1. The blue one over here, I'll do over here. I'm going to go with r plus 7 equals, less than a 10. Minus 7, minus 7. R is less than 3. So I'm going to graph the red one. I'm going to graph the blue one. And I'm going to get that final answer right here. Now we kind of put the numbers where they go. A negative 1 would be, okay, I'm going to say zeros here in a minute if you don't mind. So negative 1 would be around here, negative 1. And I'm going to the right. Shaded in. So again, 0 would be around here. Oops. 0 would be around here. 3 would be on the right. And I'm going to the left. Not shaded in. Okay, final answer would be both. Okay, so from a negative 1, my bad, negative 1, I'm going to the right, shaded in, all the way to the 3. At the 3, I'm not shaded in, and I'm going to the left. Okay, so that's my final answer for the ands. So when it comes there, now I'm going to come out here, and final answer would be where they overlap. So I'll go with a negative 1, talking about what, R's? 3. Same symbol, don't worry about it, equals, because it's shaded in, equal, not equal, not shaded in, right there. Final answer, ooh, bad. My final answer is R, the set of R such that R is between a negative 1 and a 3. And there's your answer. See, both of these are your answers. Either one are the same thing. Determine which one they look for as far as when it comes to the STAR test. Going once, going twice, what do y'all think? Okay, now we're going to come out with the inequalities containing the word or. Hold on. Okay, same thing happens here, guys, with the inequalities containing the word or. Now, the and one, it wasn't two inequalities. The answer was in two inequalities at the same time. Here, you can't be in this side and in this side at the same time. So this one's called an or, and they call this a union. Okay? Going once, going twice. So same idea. You see this part? Goes to the right. This part goes to the left. I can't be in the same spot, so I'm either here or I'm here. So that would be your answer, or statements. But you can see right now. Okay, the human ear can only detect sounds between frequencies of 20 hertz and 20,000 hertz. Right inequality, so you have to be below what? On between. Cannot hear. For them not to hear, it has to be below this one and above that one. So you can hear between here. You can't hear below this or above this. So there it is. So you can't hear below and you can't hear above. Graph it becomes this part. Frequencies below, frequencies above. The answer is both of them. You cannot hear when I'm below this much, and I cannot hear when I'm above this much. Pretty cool. It's kind of a weird thing if you think about it. Okay, a company is manufacturing an action figure that must be at least 11.2 centimeters, and at most that much. Okay, so it has to be at least and at most. Right inequality, right, and graph a compound inequality describes how tall the action figure can be. Let's go ahead and copy that down real quick while I kind of get this set up. So I'm going to draw a figure real quick. I'll draw a monito, just a stick figure if you don't mind. A company is manufacturing an action figure that must be at least okay, a company is manufacturing an action figure that must be at least 11.2 centimeters tall and at most this much. So this is the acceptable range right here. Right, and graph compound inequality that describes how tall the action figure can be. I don't like this. This is not an or. So the action figure can be in here, right? So as long as your tallness, so your domain T, is between 11.2 and 11.4, between it like this, you're good. Can it be equal to it? At least, yeah, I would say both of them can be equal to it. That's easy like that. I don't like it. It's not an or one. Forgive me on that one. Okay, so let's go to example 3. So we have this inequality here, this inequality here. Basically, solve this one. There it is. So here, add 7, divide by -2, switch the sign because you divided by negative. Wind up with that. On this side over here, you have 5m subtract 12, divide by 5. Okay. Now, this is part graph. The first one's graphed here, the second one's graphed here. So if you think about this one is kind of, when this one comes to the right, it's overlapping this one. So that's finally my answer. Just that one going through this one. So visually, look at this one. Final answer would just be this one up here, which is that one. Because this one, as it goes to the right, it already includes this answer part. So notice that the graph of the m is greater than or equal to -3 contains every point in the graph of m is equal to, m is greater than 5. So this one, it goes to the right, it includes all of these here. So the union is the graph of just that first one. Since this one already includes these, we're just going to say that's my final answer. Pretty cool, right? Let's try 3a. Okay, 3a, solve the compound inequality, then graph the solution set. So I'm going to come out here to the right. I'll solve this one in red and this other one in blue. We're going to graph it. It's an or. So we're going to go here, a plus 1 is less than a 4. And then we're going to come out here, I'll solve that one next. So we're going to go and subtract 1, subtract 1. Remember, I want the variable by itself, so I put its opposite here. It's 0 pair here. Cancel out here. A is less than 3. So when I graph this one, I'm going to go here at 3, and I'm going to the left. This one here in blue, I'll go with a is 1, 8 minus 1 is greater than or equal to a 3. So I'll add a 1, add a 1. A is greater than or equal to a 4. So 4 is over here-ish. See, that's 3, 0, 1, 2, 3, 4. Now, I'm going to the right, and I'm shaded in. Cool? So that's my final answer. You see this part here? They don't overlap here, I feel. So this is going to be my answer. Hold on, we go. Okay, so we're going to, that's my answer. I'm going to say A, right? A is my answer. The set of A is my answer such that A, this is this part here. What is that? Less than 3, or A is greater than or equal to 4. Now it's an or statement when they go opposite like that. Final graph. I forgot to put final graph. Just draw a number line like this. The 3 would be here. The 4 would be here. This one shades to the right. I'm just putting them on one number line, guys. Graphs. This one goes to the left. So this is my answer. They both mean the same thing. Let's try this one over here. I'll do this left side and then this right side. So this one right here, that was really easy. It's actually done. So I'm going to go with x is less than or equal to 9. So for my number line here, and I'm going to the left. So I'm going to put a 9 over here, if you don't mind. And I'm going to the left. You know what? Let's not do that. This is an or one, right? So a 9 would be over here, going to the left. Shade it in. This one over here in blue, I have 2 plus 4x is less than 10. I want to go to minus 2, minus 2. I'll go with 4x less than or equal to an 8. Minus 2, 8 divided by 4, divided by 4. And then we're going to go with 4x less than or equal to or 2. Oh wow, I guessed wrong. So on this number line, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? I'd have a 2 on the left-hand side, and I'd be going to the left. Shade in. Okay, so look at this one. Since this 9, you could say it's like right here, and it's going to the left from here. You see how it automatically covers this part here? So this is my final answer right here. Final answer would be this one. So we're going to go the set of x such that this is the right answer, because as this one, as this one goes to the left, it automatically covers this answer here too. It's including it. So we're just going to say that x is the answer such that x is less than or equal to 9. Final graph. 9 here. Shade it in. And go to the left. Okay, you do have an assignment now on Alex. It's called, we're in section, what section are we in? 5.4. I gave you 10 questions. Get them done, please.